Hi all, my name is Petri Kainloinen and today I'm going to talk about the integration testing of Spring Data JPA repositories. This screencast is divided into two parts. In the first part we'll take a look at a simple example application, and in the second part we'll write integration tests for the application. Our example application has a single entity called to-do and a single repository called to-do repository. Let's take a look at some code. Here is the source code of our entity class. It has four fields: the ID, description, title, and the version. The ID field is also the private key of the entity. The version field is not really relevant for this example, but I like to add it anyway because it's useful in real-life applications. If we take a look at our repository interface, we notice that it has a single method called search. This method returns all to-do entries which title or description contains the given search term. As we can see, the search is case insensitive. In the second part of this screencast, we'll write integration tests for the repository which we just saw. We can write integration tests for Spring Data JPA repositories by following these steps. First, we have to get the required dependencies with Maven. Second, we have to configure our integration tests. And third, we have to write the actual integration tests for our repository. Let's start by taking a look at how we can get the required dependencies with Maven. We can get the required dependencies with Maven by adding the following testing dependencies to our POM file. Hamcrest all 1.3.0 will use the Hamcrest matchers to verify that the data returned by our repository is correct. JUnit 4.11, Spring Test 3.2.3.release, Spring Test DbUnit 1.0.0 will use the Spring Test DbUnit to integrate DbUnit with the Spring Test framework. We also need to add the DbUnit version 4.2.9. Let's take a look at our POM file. Here is the source code of our POM file. First, we have to add the Hamcrest all dependency. The second dependency which we have to add is the JUnit. We have to also exclude the Hamcrest core because we already added Hamcrest all dependency. Third, we have to add the Spring Test dependency to the file. Fourth, we have to add the Spring Test DbUnit dependency. The fifth and the last dependency which we have to add is DbUnit. We have to also exclude the JUnit because it was added earlier. Let's take a look at how we can configure our integration tests. We can configure our integration tests by following these steps. 1. We have to configure Spring Test DbUnit, and 2. We have to configure our integration tests. Let's start by configuring Spring Test DbUnit. We can do this by 1. Configuring the DataSource bean in the application context configuration class or in the application context configuration file. And 2. Configure the actual test class. Let's take a look at how we can configure a DataSource bean. 1. We have to create a properties file which stores the configuration of the used database connection. 2. We have to configure the DataSource bean by using either a Java configuration class or an XML configuration file. Let's take a look at how this is done. The application.properties file looks like this, and we are mainly interested in this section of the file where we set the used JDBC driver class, JDBC URL, database username, and we can leave the password empty because we don't need it. Our next step is to configure the data source bean by using either a Java configuration class or an XML configuration file. Let's start by taking a look at the Java configuration class. The source code of our application context configuration class looks like this, and there are three things which are relevant to us. First, we have to use the property source annotation to load our properties from a properties file called application.properties, which is found from the class path. Second, we have to add an environment field to the class and annotate the field with the auto-wired annotation. Third, we have to create a data source bean. And we can do this by creating a new bonecp data source object, setting the database connection details, and returning the created object. Here is the source code of our application context configuration file. This file has the same configuration than the Java configuration class which we saw earlier, and there are two things which are relevant to us. One, we have to use the property placeholder element of the context namespace for loading our application.properties file from the class path. Two, we have to create a data source bean and set database connection details. Okay, we have now configured the data source bean. Let's take a look at how we can integrate Spring Test DbUnit with our test class. Well, we can do this by annotating the test class with the test execution listener annotation and using the following test execution listeners. The listeners are shown on the screen, but I'll go them through one by one and explain what the purpose of each listener is. The dependency injection test execution listener adds support for dependency injection and initialization of tests. The dirties context test execution listener processes test methods which are annotated with the dirties context annotation. The dirties context annotation indicates that the test method dirties the application context for current test. The transactional test execution listener adds support for transactions by using the transactional annotation. The DbUnit test execution listener adds support for DbUnit annotations. In other words, it ensures that Spring Test Framework processes the DbUnit annotations which are found from our test classes. Okay, let's take a look at how our test class is looking at the moment. After we have added the test execution listeners annotation to our test class and provided the required listeners as its value, our test class is looking like this. We are almost finished with our configuration. However, there are still a few things which we have to do before we can start writing the integration tests. The final phase of the configuration consists of these steps. 1. We have to ensure that the test is run by using the Spring JUnit 4 test runner. 2. We have to configure the used application context configuration class or configuration file. 3. We have to add the Spring Test DbUnit configuration to our test class. And 4. We have to add the to-do repository field to the test class. Let's take a look how our test class is looking at the moment. After we have added the configuration to our test class, its source code looks like this. Let's go through the configuration one more time. The first step was to use the run with annotation to configure the correct test runner. Second step was to use the context configuration annotation to configure the used application context configuration class or application context configuration file. The third step was to add test execution listeners annotation to the test class and specify the used test execution listeners. The last step was to add a to-do repository field to the test class and annotate the field with the auto-wired annotation. That's it. We have finally configured our integration tests and we are now ready to start writing the actual tests. We can write the integration tests by following these steps. 1. We have to configure the used DbUnit dataset, and 2. Naturally we have to write the actual integration tests. Let's take a look at how we can configure the used DbUnit dataset. Well, we can do this by 1. Creating a DbUnit dataset file, and 2. Configuring the used dataset in our test. Okay, we have created a DbUnit test file which uses the flat XML format, and let's take a look at how it looks. The name of the DbUnit dataset file which is used in our integration tests is tododata.xml, and we use it to create a small dataset which has 2 to-do entries. Okay, let's take a look at how we can configure the used dataset in our tests. Well, we can do it by using the database setup annotation. If we add the database setup annotation to a class, the same dataset is used to initialize the database before each test method found from that class. On the other hand, if we want to have different datasets for different tests, we must add the database setup annotation to a test method. Let's take a look at how this is done in our example. Okay, because our integration tests uses the same dataset, we have added the database setup annotation to our test class. We are finally ready to start writing the actual integration tests for our Spring Data JPA repository. Let's start by taking a look at some general testing guidelines. We should not write tests for methods provided by the used persistence framework. This makes no sense since these methods are already tested by the developers of the used framework. However, we should write tests for each database query created by us. Also, we should remember to follow the best practices of DbUnit. The link of these best practices is found from the description of this video. So, when we have followed the testing guidelines which we just saw, we have created 3 test cases. 1. We should write a test case which tests a situation where no results are found. 2. We should write a test which ensures that when a title of a to-do entry matches with the given search term, the correct data is returned by the repository. 3. We should write a test case which ensures that when the description of 2 to-do entries matches with the given search term, our repository returns the correct data. Let's take a look at how we can write these tests. Our first test ensures that when no to-do entries are found, our repository should return an empty list. We can write this test by calling the search method of the to-do repository interface and using a search term which is not found from the database. We also have to verify that the size of the returned list is 0. Our second test ensures that when the title of a single to-do entry contains the given search term, our repository returns a list of to-do entries which has only one to-do entry. We can write this test by calling the search method of the to-do repository interface and using a search term foo. Now, if we take a look at our dataset file, we notice that the first to-do entry has a title foo. Now, we have to ensure that the size of the returned list is 1. We also have to ensure that the list contains the correct to-do entry. And we can do this by getting the first item of the list and using hamcrest matches to verify that its information is correct. Our last test ensures that when the description of two to-do entries contains the given search term, our repository returns a list which has two to-do entries. We can get a list of to-do entries by calling the search method of the to-do repository interface and using a search term IPS. Now, if we take a look at our dataset file, we notice that the description of both to-do entries contains a string IPS. Okay, so now we are ready to verify that the list contains the correct to-do entries, and we can do this by ensuring that the size of the list is 2, and in the second step we'll use hamcrest matches to verify that the list indeed contains both to-do entries. Okay, we can now run the integration tests and see if the search method of to-do repository interface is working as expected. And as we can see, all tests passed. We have now written some integration tests for a Spring Data JPA repository. Let's spend a moment to summarize what we have just learned. We learned what kind of tests we should write for our repositories. We learned how we can configure a Spring Test DbUnit and how we can integrate DbUnit with the Spring Test framework. We also learned how we can use hamcrest matches for ensuring that the data returned by our repository is correct. That's all for today. If you are looking for more Spring-related tutorials, you can check out my website www.petrikainulainen.net. Thanks for watching. Hei hei!